So based on the work that you guys were submitting in the last assignment, I need to make another video and have you guys watch this because a lot of you were making some mistakes, either with showing me exactly how your work should be shown or with solving them incorrectly, period. So I want to just reiterate some things, and then we're going to go through 4 examples together, and that'll be it. So this video shouldn't be that long, but I am going to do explaining and telling you exactly how I want to see your work. And when we do get back into class, we will work with some hands-on activities, some algebra tiles and things like that to kind of show you this as well. All right, so what we're still doing is solving one-step equations. All right, soon I am going to challenge you guys of solving 2-step or multiple-step equations, but I do need to wait until you guys are really comfortable in showing me exactly how that you know how to solve these. Soon you will be needing to write me your answers out, and your thought process is going to be more important than anything else. Right? And one of the things that you need to do that some of you were not doing is you need to isolate your variable. Right? And what that means, isolating your variable, it means rewriting an equivalent equation in which the variable is on one side of the equation. So that means we're trying to get our variable x all by itself on one side of the equation. And everything else is on the other side of the equation. Right? So that means if we were doing 5 plus 3 times 2, whatever it is that we're doing, everything else is being on one side of the equation, and our variable is all by itself on the other side, right? So some of you are making the mistake, and I'll show you guys what you're doing in a second. All right, and when the equation involves addition or subtraction or multiplication, division, any operation, we will use the inverse operation to undo the operation in order to isolate the variable. So let me just show you an example real quick. One of the questions may have been x plus 5 is equal to 8. And what some of you were doing is you were subtracting 8 from this side and moving it over here. And then you were getting x minus 3. And you're saying x is equal to negative 3. Now, this is not correct because if you think about this, we are trying to isolate our variable, meaning we're trying to have our variable all by itself on one side. You are moving this 8 to the same side that the x is on. All right, so I am going to show you another way that you guys can do this to try and help you in knowing where you need to move your numbers and how you need to move them. All right, so just make sure that you are paying attention, that you are following how I'm showing you my work, because that's how you need to show it as well. Right, because some of you are just doing guessing and checking. I'll show you what I mean by that when we get to some examples. All right, so let me go ahead and let's get started on some of the questions. All right, I am going to first show you how I want you to be doing this. I'm going to show you something new. And some of the ways that I've seen or people have taught this in the past is they'll draw a line down through the equation sign. And the reason why is because when we're trying to solve for our variable, we know that we're trying to move everything that's happening to our variable to the other side of the equation. So maybe you might want to circle this and draw an arrow saying that you're going to move it to the other side. And then you would actually move it. So I need to ask myself, what is happening to this variable? Well, right now we are subtracting. Well, what is my inverse operation of subtraction? That is addition, because we want to isolate that variable. So we want to get it to say x plus 0. And we know for subtracting 13 and we add 13, that gives me 0. So that means what I would do here is x minus 13, and then I need to move this to the other side, so it's plus 13. And what I do to one side, so it's equal to 37, I must do exactly the same thing to the other side. So now, by doing this, x minus 13 plus 13, this is equal to x plus 0. Well, do I need to write x plus 0? No, because x plus 0 is just x. But you see how it isolated my variable. And now I can go ahead and I can add 37 plus 13, which is then going to give me 50. So my answer is x is equal to 50. All right, I'm going to show you what some of the mistakes I saw were. So over here, what some of the people were doing is they were saying plus 13, and then they were just doing that x is equal to 50. Now, you're not technically showing me your work properly here, because how did this x minus 13 all of a sudden equal to x? How did you get to that? And where did this plus 13 come from? And we know if we add something to one side and not to the other, it's going to make our equation no longer equal to each other. So you must show me your work. So you must show me either like I did here. I'll highlight this, I'll start. And the other way that you can show me your work as well is if you had x minus 13 is equal to 37. If you guys are able to identify what it is that you need to do right away, you could still draw this line going down the middle. But then what you could just do is you can show me your work by doing your additive inverse here, and we're adding 13 to both sides. And I know that this minus 13 plus 13 is going to cancel each other out. So x is then going to be equal to 50. All right, this or this would be acceptable for showing your work. All right, I am going to, I'll just leave this like it is. All right, so now let's move on to number 2. I'm going to rewrite it so it gives me space to actually show my work. So x divided by 9 is equal to 12. So once again, I'm going to just draw this line going down my equal sign because I know as I move from one side to the other, I need to make sure I'm doing the same thing to both sides of that line. I can't just all of a sudden add to one side. I need to do it to both. Or whatever operation I'm doing. So when I look, I say, okay, it is being divided. So my x is being divided. I need to get this all by itself. So in order to move this to the other side of the equation, I need to ask myself, well, what is the inverse operation of division? And that is going to be multiplication. So that means I will multiply this side by 9 because I know when we're dealing with multiplication or division, our goal is to get it to 1 because x divided by 1 is equal to x, or x times 1 is equal to x. So just like we were able to rewrite this here and get our x all by itself, we could do the same thing when we have it broken down to 1 with multiplication and division, right? And what I do to one side, I have to do to the other. And I know that, well, 9 times x divided by 9 is going to give me 1 times x, but I don't need to write 1, so x is simply equal to. And then I could do 12 times 9, and 12 times 9 is going to give me 108. Right? This is the work that you need to show me. This is the work that you need to show me. Right? What some of you guys are doing is you're giving me guessing and checking. Like for instance, some of you for this one might be able to tell in your head what the answer is, and you just go straight to the answer and say, well, 17 plus 44 is equal to 61, so x is equal to 17. That will not get you any credit. Right? You must be showing your work, and your work here is your inverse operations. So I'm going to go ahead, I'm going to draw this line going down my equal sign. I'm going to ask myself, what is being done to my variable? Well, right now I'm being added. So what is my inverse operation of addition? That means it's going to be subtraction. So now in order to move this to the other side of the equation, I need to subtract 44. And now from here, I know I'm going to have x plus 0, which I don't need to write. I can just write it as x. But now that I'm drawing this line, maybe it jumps out, okay, I'm not doing it to both sides. So now I can say, all right, well, then this is going to be 44, minus 44 as well. And 61 minus 44 is 17. And that will be my final answer. Right? So you must be showing me your inverse operations, whether you draw it, write it next to here like I did for problem number 1 and from problem number 2, or whether you write it below like I did for this one here. All right, and now for problem number 4, we are then going to once again draw this line. And now I'm going to ask myself, well, how do I move this 6 to the other side? Well, right now it is being multiplied. Well, what is my inverse operation of multiplication? It is division. So that means in order to isolate this variable and get it all by itself, I need to divide by the number it's being multiplied by, and that is 6. And once again, by doing this, it will give me 1 times x, which we don't need to write. We can just write it as x. And now what we do to one side, we must do to the other. And 48 divided by 6 is then going to give me is then going to give me 8. All right, and that would be our final answer. So the way that you must show me your work is this. Show me your inverse operations. All right, I'm going to erase this here in the middle because it is a little bit harder to read and looks a little sloppy with all of that. So let me erase this. And just another thing, when you guys are giving me your paper, your work, and you're submitting it, please remember that you are boxing each of these off. All right, so each one of these problems is going to be boxed off, and that this way I can easily and clearly see your work. All right, so that is it for this video.